Hello students. So today we will start physics video number 8. So all of you please open page number 9. Okay. So in the previous video we have discussed about unit 3, that is our about the vernier calipers. Okay. So we will have some definitions today. So first definition is the pitch. Okay. So what is pitch? Pitch is the smallest value of length or any other unit which can be read directly from the main scale. Okay. So main scale we have already discussed, vernier scale we have already discussed. Okay. So pitch is the smallest value of length. Okay. It will be the smallest value of length or any other unit which can be read directly from the main scale. Okay. That value should be read from the main scale. So for example, suppose 1 centimeter length has 10 divisions. Okay, 1 centimeter length has 10 divisions because 1 centimeter can be written as 10 millimeter. Okay, so then pitch will be our 1 by 10 because in the vernier in the main scale we can read up to 1 by 10 centimeter, and 1 by 10 centimeter means our 0.1 centimeter, or 0.1 centimeter, that means will be our 1 millimeter. Okay, so here the pitch will be our 0.1 centimeter. However, if one candidate if 1 centimeter has 20 division, okay, suppose if we have 1 centimeter has 20 divisions, then our pitch will be 1 by 20 centimeter, that will be our 0.5 centimeter. Thus we have got the formula of pitch. So you have to remember this formula. You have got the first formula. Okay, so what is pitch? Pitch is the one unit, that is your length divided by number of division in the unit. Okay, one unit, that means 1 centimeter or something. So 1 divided by number of division. If division is 20, take 20. If division is 10, so 1 unit length means 1 unit, 1 divided by number of divisions. Either it may be 20 or it may be 10, such that. Okay, so this will give you our pitch. Next we have our least count. Okay, these are all practical based. Okay, so as in this online session we cannot do the practicals, so just understand it. Okay, so least count, so just go through the definition. So least count is the magnitude of smallest measurement which can be measured by an instrument. It is the magnitude of smallest measurement, or you can say that the measurement of smallest measurement that can be measured with an instrument, and that is called our least count. Okay, or we can say that you can use any of the two definition, any one of the two definition, and the difference between one main scale division and one vernier scale division is also least count. So this will be, we can say that the proper definition, that is, it is the difference between one main scale division and one vernier scale division, that will be our least scale. Okay, so now how we will calculate the least count of a vernier calipers? Okay, so least count of a vernier calipers is the difference between one main scale division, one MSD, and one vernier scale division, that is one VSD. So least count LC will be our one main scale division will be 1 millimeter and one vernier scale division is our 0.9 millimeter. We have already discussed about that. So if we see, it is our 0.1 millimeter, or if you convert it into centimeter, this will be our 0.01 centimeter. Okay, so if you see the formula, so there will be two formulas. This one, so least count will be smallest value of 1 MSD divided by number of VSD. Okay, MSD will be your main scale division and VSD will be vernier scale division, or you can use this formula also, pitch by number of VSD. Okay, so just remember this too. So you try to do this one. Okay, how to use the vernier calipers. So if you read this point 1.14, you will easily get it. Okay, figure is given, and if you find it difficult, then you can contact me. I will give you I will explain this. Okay, it is very easy, that's why I am skipping this. Okay, so zero error of vernier calipers, this is also same. So for a correct measurement, the zero of the main scale must coincide with the zero of the vernier scale. You can see that the zero, this is our main scale, this one, the longer one is our main scale, and this is one our vernier scale. And so for correct measurement, these two must be same, that is the zero of main scale, if the zero is here, then the zero of the vernier scale must be also in this line, then only we will have the correct measurement. Okay, so when the movable jaw is in contact with the fixed jaw, okay, however if the zero of the main scale and vernier scale do not coincide, then the vernier is said to have an error. So you can see that figure. Okay, so your 0 of main scale and vernier scale are not coinciding. That means that will have some error. So now error can be your positive error or it can be negative error. Okay, so positive error, when it will be positive error, if the 0 of the vernier scale is on the right side of the 0 of the main scale, you can see this this 0 is towards the right. Whose right? Right of the main scale. Then we will say it has a positive 0. Okay, and if the correction is said to be negative, when this 0 will be towards the left, then we will say it is a left 0. Okay, and in order to calculate positive 0 or negative 0, look for the vernier division which coincides with the main scale. So you can see which one is coinciding. So this one is not coinciding, this one is also not coinciding, this one is also not coinciding, this also not coinciding, this also not coinciding, but this one is coinciding, this one. Okay, this one is coinciding with the main scale as well as with the vernier scale. Okay, so in figure 1.6, this figure, in figure this, the sixth vernier division coincides with the main scale division. So the correction is then calculated by the formula. So how to calculate the correction? Correction will be our minus coinciding division of vernier scale. Coinciding division is your 6, is the coinciding division. You have to put one negative sign into least count. Least count we have already calculated. So this is our 0.1 centimeter. So our correction will be minus 0.06 centimeter. Okay. So in the previous example, corrected reading will be, what will be the corrected reading? So corrected reading will be our observed reading plus correction. Okay, correction is this one. The formula of correction is this one. So you note down this two. Okay, so negative error will be also same. If the your 0 is 0 of the vernier calipers is in the left, if this 0 is in this side, then we will say it is a left error. Okay, so all will be same. The formula of correction will be different. Okay, here in the right correction, right error correction, the formula we have got the formula of the correction, this two, and our corrected reading is also this one. And for negative 0, and the formula of correction is this one, that is plus n minus coinciding division of vernier calipers into least count. Now you can see what is n. So n is the total number of vernier scale division, total number. Okay, so if you see, the total number of vernier scale division is 10. So in this way we can do it. Fine. So next we will move to our micrometer screw gauge. Okay, so micro screw gauge, before going to this unit number 5, there are some numerical problems. Okay, after at the end of this we have one numerical problem. This is on page number 11. Okay, so you do the practice problem 1, 2 and 3 and 4. Okay, so you try to solve all this. If you can't solve it, then you request me, then I will give you the solution. Okay, but try on your own. So if you can't solve it, then only you request me. Okay, then I will make one video on this, or I will give you the solution. Okay, but you have to try it. You can see the some questions are also given, solution are also given, and it will use only two formulas, that is your pitch and least count. Okay, so we will now move to our and there are some exercise also. You can take exercise 3, this to be also homework. Okay, so all of you please open the page number 13. In this you can see that in exercise 3, who have invented vernier calipers. So you can find this, who have invented vernier calipers. Okay, so if you search this on the internet, you will get the answer. Okay, who have invented vernier calipers. Similarly, what is the need of the measuring length using vernier calipers? So you will find it in page number 8 or 9. Okay, why we use it. So questions are very simple. So I will try to send the solution. Okay, but you try to solve the practice problems in page number 9, 10 and 11. Okay, or in page number 11 and 12. Fine. Okay, now we will move to unit number 4, that is our micrometer screw gauge. Okay, so first you need to know what is micrometer screw gauge. So it is an instrument used for measuring the diameter of very thin wires or objects, okay, and its accuracy is up to 0.001 centimeter. So it can measure very thin wires, but with the help of our vernier calipers, its division was up to 0.01. Okay. So with this help of screw gauge, we can measure very thin wires also, okay, and we can calculate the diameter also, and it's commonly used in micrometer, and it is commonly called as micrometer screw gauge. Okay. So construction part, you do it on your own construction part, because these are only practical things. So you can see different parts in the figure. You can see the different parts, okay. Parts name are given. So there are many parts. So first part is your U frame, okay, this will be the U frame, then nut and screw, and then thimble or circular cylinder, slip cylinder, baseline, circular scale. So you can easily calculate that. Okay. So now I will teach you how to calculate the determination of pitch of a screw. Okay, how we will calculate the pitch. So this is the formula. So you have to remember this. In order to determine the pitch, the screw is given 5 complete rotation and the distance moved by the thimble on the main scale is recorded, and the pitch can be found using the formula. That is distance moved by the thimble on main scale and the number of rotation of thimble. MS means your main scale. Okay. So suppose if 5 millimeter is the distance moved by the thimble on the main scale, and for 5 rotation, then our pitch will be 5 millimeter by 5. So that will be our 1 millimeter. Okay. Similarly, we can calculate the least count of the screw. So least count of the screw is the smallest distance moved by its tip when the screw turns one division marked on it. Okay. So these are very simple. So we have the formula for least count also. So you can use this formula. So to calculate the least count, you need to first calculate the pitch. So pitch divided by number of CS division, and CS means circular scale division. Okay. Suppose you can see this example. If pitch of a screw is 1 millimeter and the number of division marked on its thimble is 100, then our least count will be the pitch of screw is 1 millimeter. So pitch is given and divided by number of your circular scale. So number of circular scale is our 100. So this will be 1 by 100. So if we divide it, we will get 0.01 millimeter. Okay, or if we convert it into centimeter, this will be our 0.001 centimeter. Fine. Okay, so there are some experiments given or steps given to measure the diameter of the wire. Okay, so you read this. Okay. So there will be two again formulas. So observed diameter, it will be the main scale reading plus circular scale reading into least count, and true diameter will be our observed diameter plus minus 0 error. So you can calculate, get the observed diameter as well as our true diameter. Fine. So you can see this figure. Okay. So how we will so this is same as that of the vernier calipers almost. Okay. So we have to use how to calculate the determination of 0 error, positive 0 error, then negative 0 error. So for each case we will have the formula. Okay. So you can see in figure 1.12. In figure 12, the main scale reading is 5 millimeter. So you can see the main scale reading. Which one will be the main scale reading? So this is our main scale reading, and this will be our circular scale reading. Okay. So the main scale reading is 5 millimeter, and the 57 circular scale reading coincides with the baseline 57. So this will be 55, 56, 57. 57th is coinciding. Okay. So if you see, so our observed diameter will be main scale reading. So main scale reading is 5 millimeter plus circular scale reading. Circular scale reading is our 57 into least count. So what will be least count? Least count we have already calculated. That is our 0.01. So if you multiply it, we will get the answer. Okay. So now how to calculate the zero error. So if the 0 of the main scale does not coincide with the 0 of the circular scale on bringing the screw and B in contact with stand A, then the micrometer is said to have 0 error. Okay. And similarly positive 0 error if the 0 line marked on the circular scale is below the reference line of main scale, and if it is above the main scale, then it will be said to be your negative work. Okay. So negative zero error. Similarly, okay, so there are some formulas related to this. That is your corrector diameter. So you have to remember this corrector diameter for positive zero error, and similarly we have our negative zero error, and the formula will be this one. Okay, so you can match this formula with the vernier calipers. Fine. So up to this you solve try to solve the practice problems. Okay, so practice problem are also very easy. You can use those formulas which I have marked. Okay, so after solving, so if you find any difficulty, then you can contact me. I will give you the solution. Okay, now we have 2 or 3 topics left, so we will try to complete the unit or complete the chapter in the next video. Okay, so we have some topics. After that we will discuss it. Okay, or what we can do, we can still discuss unit number 5 and 6. Okay, so wait, so we will discuss it now only. Okay, so all of you please open page number 19. So we will discuss this unit 5. Okay, so we have our measurement of volume. Okay, measurement of volume. So how we measure the volume? Okay, so we observe that in our daily life, generally what we do for volume, a bucket is bigger than mug. How we can say that bucket is bigger than mug? Because there will be more volume of water in the bucket than in the mug. Okay, a drawing room is bigger than a store. Then a teacher's table is bigger than a chair. Okay, it means that generally we are comparing. That means we are talking about the volume of the bucket. That is, it means that the volume of the bucket is more than the volume of the mug. And the same is true for the room. Volume of your drawing room, because the drawing room is bigger than the storeroom. So it will have more space in drawing room than in the store. Okay, and the space occupied by a substance, that is, it may be solid. So what is volume? So volume is, it is the space occupied by a substance. That substance may be solid, liquid or gas. It's called our volume. And what is the unit of volume? The SI unit. Okay, System International, SI. SI unit of volume will be our cubic meter. It can be written as m⁻³ meter cube or cubic meter. Okay, so 1 cubic meter, some definition may also ask that 1 cubic meter is the volume occupied a cube whose each side is equals to 1 meter. Okay, why? For because volume is length into breadth into height. So unit of volume is meter cube. So if you multiply 1, so we have to take 1 meter into 1 meter into 1 meter. So how we will define the 1 meter cube? 1 cubic meter is defined as the volume occupied by the cube whose dimension have 1 meter, 1 meter, 1 meter. That is, each side is equals to our 1 meter. So you have got the 2 definition. That three thing. What 3 thing? The definition of volume from here, the unit of volume from here, and the definition of 1 cubic meter from here. So you have got 3 things. Okay, so you write it, and the smaller unit of the volume is our centimeter cube. Okay, smaller unit, because meter is bigger and centimeter is smaller. So smaller unit will be centimeter cube. And now we will have to we have the comparison. Okay, or yeah. So 1 meter cube or 1 centimeter cube is the volume occupied by a cube whose side is equals to 1 centimeter. Okay, and similarly 1 cubic meter, 1 cubic meter and 1 cubic centimeter. Okay, so 1 cubic centimeter will be the volume occupied by a substance whose side is equals to 1 centimeter. That means the length will be 1 centimeter, breadth will be 1 centimeter, and your height will be also 1 centimeter. So that means 1 meter cube can be written as 1 meter, 1 meter, 1 meter. Okay, and we know that 1 meter equal to 100 centimeter, 1 meter 100 centimeter, 1 meter 100 centimeter. So if you multiply, what we have got? 3, 2, 2, 1, 10, 100, 1000, 1000, lakh, 10 lakh, 10 lakh centimeter cube. That means 1 meter cube equal to 10 lakh centimeter cube. Or if we try to change it, 1 meter cube, if we calculate 1 meter cube, 1 by this 10 lakh 10 lakh will be get divided on the left hand side. Okay, so if we divide it, so what we will get? 1 centimeter cube. So this is one your formula, this one formula is there. So 1 meter cube equal to this much, and 1 centimeter cube is equals to this much. Okay, so if I write in the mathematical way, okay, so 1 meter cube is equals to, how many zeros are there? 1 2 3 4 5 6. It is 10 to the power 6 centimeter cube. And if we convert 1 centimeter cube, then we have to transfer this 10 to the power 6 towards the left. As it is multiplying, if we transfer it to the left, it will get divided 10 to the power 6 meter cube. And in the negative powers, this can be written as 10 to the power minus 6 meter cube. So 1 meter cube equals to 10 to the power 6 centimeter cube, or 1 centimeter cube equals to 10 to the power minus 6 meter cube. So you remember these two formula, these two conversions. Okay, these two conversions will be necessary to do general calculation. Okay, so now generally the volume of the liquid here. Okay, next part, the volume of the liquid is measured in millimeter or liter. Okay, 1 liter water or 2 liter water, that means we are giving the volume. Okay, or if we take small quantity like vaccine, okay, or any injection, so that is measured in milliliters. Okay, 10 ml, 15 ml, 20 ml, 5 ml, like that. So generally the volume of liquid is measured in either millimeter for small quantity, and larger quantity we use liter. So 1 liter is equal to the volume of 1 kg of water at 4 degrees Celsius. So sometimes when you buy something, suppose oil, okay, either mustard oil or refined oil or any liquid thing, you will see that it is written as 1 liter. But if you convert it into kg, the kg will be not exactly, you can say that 1 kg. Okay, it may be below. So when it will be, your 1 liter will be equal to 1 kg. So this is the condition. That means our 1 liter will be equals to 1 kg of water only if the temperature is 4 degrees Celsius. At 4 degrees Celsius, both the liter as well as the kg coincides. Okay, so a smaller unit of volume of liquid is also your cc. Okay, smaller unit of volume is also cc, that is cubic centimeter, not the bike cc, that one. Okay, cubic centimeter. So, or milliliters. Okay, so 1 liter is equals to, you will get another relation, that is 1 liter equal to 1000 cc or 1000 ml. So you remember this formula, you remember this formula, then you remember this formula, and you remember this formula. Okay, that will be enough. Okay, so similarly you can convert that 1 meter cube equal to 10 to the power 6 centimeter cube. We have already learned this. 1 liter equal to 10 to the power minus 3 meters cube. Okay, so you remember this. 1 liter equal to 1000 centimeter cube, 1 milliliter equal to 1 centimeter cube. So 1 ml will be our 1 cc, that is cubic centimeter, and 1 liter will be 1000 milliliter, we know this. And if you convert into centimeter cube, this will be our 1000 centimeter cube. So there are some units you need to remember it, okay, while measuring our volume. So volume of a rectangular body. Okay, how we will calculate the volume of a rectangular body? So for finding out the volume of a rectangular body, we have to find out the length, breadth and height of the rectangular body. Suppose we have the rectangular body, means in the situation you can say that cuboid. Okay, so for cuboid, what we have? We have the length, breadth and height. This will be length, this will be breadth, this will be height. We have length, breadth and height. Okay, so we need this. So what will be the volume of the rectangular body? So this is the volume of the rectangular body, that is length into breadth into height. So you remember this formula. Okay, very easy. Now we will move to the measurement of volume of liquid. Measurement of volume of liquid. Okay, so we will use the different instruments. Here, the volume of a liquid may be measured with the help of different measuring vessels. Okay, you can see it in some instrument when you buy it, some marking are there, 0.5 liter, 1 liter, 1.5 liter, like this. Okay, so the first is our measuring cylinder. Okay, so you can see this measuring cylinder in the lab. You will see the measuring cylinder like this. Okay, measuring flux, nozzle, burette. Okay, burette. Okay, this is our burette. Similarly, so first we will learn about the measuring cylinder. So it is a graduated glass or plastic cylinder in milliliter. Okay, so this measuring cylinder will be made either of the plastic or of the glass. Okay, and in its marking will be in milliliters, that is 0 ml, 10 ml, 20 ml, 30 ml, or 100 ml, like. Okay, we cannot measure large volumes in liters. Okay, so it is normally used for measuring the desired volume of liquid, and measuring cylinders are available in different capacities. Okay, we can find larger measuring cylinders which can measure in liters also. Okay, so you can see the different one. Our second one is your, you can see the bottom is your spherical, that is measuring flux. So measuring flux, this flux has a long narrow neck provided with a stopper at graduation mark is done at the neck. Fixed volume of liquid up to the mark is filled in this flux. Okay, so you can see the marking here, you will see some marking here. Fine. Next we have our nozzle or pipette. So it is a glass tube with a cylindrical bulb in the middle. You can see the cylindrical bulb in the middle, this one, cylindrical bulb. Fine. So the tube has a narrow nozzle at the end, and when pipette is filled with the mark, it has a fixed volume of liquid, and its lower end is dipped in liquid and is sucked up end. Okay, so this portion will be dip in the water or any liquid, and from the mouth we have to suck the water from here. So from our mouth we have to suck this. Okay, then water will rise up and we can see the measurement from here to here. Okay, so desired ml and desired amount of water can be measured using this instrument. The next is our fourth instrument is our burette. So burette, it consists of the narrow glass tube marked in ml and provide with a tap at the lower end. See, you can have the tap at the lower end, so you can control the flowing out or flowing in of the liquid. So each ml is divided into 10 equal parts and marking is from top to bottom. Okay, so marking will be from top to bottom. You can see it 10, 0, 10, 20, 30, like this. Okay, so we have done the measurement. We have seen the different instrument to measure the volume of liquid. Next we will see the measurement of volume of irregular solid bodies. Okay, irregular, suppose this type of shape which do not have any definite shape, definite geometrical shape. So how we will measure the volume of that? Okay, so it is very easy concept. How easy concept? Just I will give you the basic overview. Suppose you have taken a measuring cylinder. Okay, in measuring cylinder we have taken suppose 60 ml of water. Suppose 60 ml of water. Okay, and if we put this irregular shape inside the measuring flux, then you can see the rise in water. Okay, rise in the water. So suppose it was starting 60 centimeter, and after inserting this finger, suppose the water have risen up to 80 ml. So what will be the difference of these two? So difference of these two will be 20 ml. So in this way we can calculate the volume of an irregular bodies. Okay, so you go through these cases, case 1, case 2 and case 3. Okay, so you will find the answer. Okay, so very easy. So in the next video we will try to solve the measurement of mass. Okay, we will discuss about the measurement of mass. So up to this, after this you will find some exercise 5 also. So you try to solve that one. Okay, and if you find any difficulty, then contact me. Mostly only 2 or 3 students are contacting me or doing their homeworks or noting down, and I don't know why everyone is not sending the notes. Okay, so try to solve it. If you find any difficulty or if you are not understanding, then contact me. Okay, I will try to help you. Thank you.